Hare Krishna everyone. Today we'll try to solve one trigonometric proof. So you can see there is m square minus n square given in the proof, which indicates a formula called as m minus n into m plus n, which is a basic algebraic formula. So the first thing which indicates us that we have one equation this and the second equation this. So if I add these two equation, I can find m plus n, and if I subtract these two equation, I can find m minus n. So the same thing I'll do here. So first I'll add. So while adding, m is equals to tan theta plus sin theta, n is equals to tan theta minus sin theta. So this is a linear equation kind of stuff. So if you add this two equations, it will be m plus n, which is equals to tan theta plus tan theta is 2 tan theta, and plus sin theta and minus sin theta will get cancelled. And the same equation, when you subtract, it will somewhat look like this. So now you are subtracting, so there will be a minus sign here. There is a minus sign here, there will be a plus sign. Now this is going to be m minus n. This plus tan theta and minus sin theta, sorry, plus tan theta and minus tan theta will get cancelled. This will be 2 sin theta. So this will be your equation number 1, and this will become your equation number 2. Let's multiply these two equations. So it will be like m plus n into m minus n. That will be 2 tan theta into 2 sin theta. So this thing I can write like as if m square minus n square according to the formula, and this will be 2 to the 4 and tan theta and sin theta. So this thing we don't want here. We want root mn. So what we have to do is like we have to prove this thing as equals to this thing. Then we can compare the equation and we can prove the thing. So this will be my equation number 3. Now what I want is m into n. So I have mn here. So I'll simply multiply m and n. So it will be looking like this. I will multiply m and n. So it will be like m into n is equals to this into this. And it's going to be tan theta plus sin theta and tan theta minus sin theta. So now this is also in the form of a plus b, a minus b. So now a plus b, a minus b is a square minus b square. Okay. So now we can use basic stuff here. So I'll convert tan theta as sin theta, sin square theta by cos square theta minus sin square theta. I just wanted to convert this tan theta into some of the relation of sin theta. So now I have noticed that there is a common here, sin square theta and sin square theta. So I'll remove sin square theta as common, and here there will be 1 upon cos square theta minus. Now you have removed sin theta outside, so there is nothing here, so you can keep it 1. Okay. Now what I can do is I'll keep this sin theta like this only, and I'll see what can I do here. Now this is 1 minus. Now you can multiply here, so it will be cos square theta upon cos square theta. I'll continue this side. It will look like m into n is equals to sin theta I mean sine square theta, and this will 1 minus cos square theta is sine square theta. So I can write here sine square theta, and here in the denominator there will be a cos square theta. And you know a few of trigonometric ratios, that sine upon cos is 10, and there is a square, so I have to write 10 square theta. So I don't want, I want a root over here, so I can just apply square root on both the sides. So it will look like this: root m into n is equals to sine theta into tan theta. Okay, so this will be my equation number 4. As I have found that sine theta into tan theta into sine theta is under root of mn, and I can see the same thing here as well. So I can just compare this both the equation, and I can write m square minus n square is equals to 4 under root of mn. So this is a very simple equation, simple proof that you can solve. The only thing that you have to know is like just what you can see in the proof side, and you can think about it. You should know the basic ratios and basic identities. And for any other videos or any other doubts, if you get, you can write a comment down and just subscribe our channel so that we can get back to you whatever doubts you must be having. Thank you.